Hello and welcome back to the development of the Feersum scheme compiler. So in our last stream I was looking at implementing the last of the macros for some time. I went over adding some new support for the built-in compiler macros, and I can't remember, just general other refactorings to do with macros. It's been a while. Since then, I have been doing some general updates on the actual library Serifa, which has all of our general methods that are available to Scheme. So, for example, we now have character methods, which implements most of the character methods that are required by the Scheme library, and so on. This is all written in C#, and where I'd like to go today is to look at changing our compiler so that we can emit a library instead of emitting just an executable, so that we would be able to rewrite this and other bits of code like it into Scheme. So we could have a Scheme library that compiles into the same .NET assembly, because these methods here, like this char less than equal, is just a static method which takes an array of objects and returns an object. This is conforming to the calling convention that we use for the Scheme methods that we emit. So we could just have it so that we compile our Scheme into a library, and then with the right method attributes on it, we could have this, rather than Lisp built-in, maybe we have a Lisp method attributes that we attach to everything, and then maybe some kind of assembly level attribute as well to control, just to mark up the code that we emit, so that we know when we reference the library later on. So the plan is to start off at the main program. First thing you want to do is have a look at how we model our arguments already. So we have a version, a build configuration, Boolean for interpreting, we have the output, and we have a list of sources to compile. So what we want here is another command line argument, which I think I'm going to call output type, and be output type. We should try and generate that. No, can't generate it automatically. Just want to go in here. Yes. Type output type. So the types that we support already is an executable, the ones we're going to add are library, and I think we might also want a script flag, just to kind of model the scripts that we generate as far as the REPL is concerned, in the same way that we're modeling the other kinds of output types. So the difference between a script and a standard exe is that when we generate an exe, we make a main method, whereas with a script, we generate a $script building method. So other than that, they are effectively the same. Now, what do we want to do? We've got, this should parse all of our arguments. Then we'll want to do the same thing we do here with build configurations and do output type and then effectively default it. So we say arg start output type and then default it with option. Well, it's just going to be output type X, isn't it? Yes, remove that redundant qualifier. And then we can do we want compilation options? I think we might do, which is just going to have all of our different configuration options in. Don't know if we want the source and target paths to be in there though. Maybe not for the time being. Compilation options. This is where I start to forget what F# looks like. We're gonna have an build configuration. Build configuration. Output type. And I think that wants to be like that. It does. Options for each compilation. Hopefully this will be the last time we need to refactor this. I guess we can just do this like this. Configuration and then do that. Actually, let's just back that out. We can just go configuration is build config and output type is output type. Then we can use our options down here. And in compile singles, we'll take an options instead. I mean, it doesn't actually matter what it's called here, but compile file should then take an options. Why are you not allowing me to type? Oh dear. Then yeah, here we can have options, and then then every time someone says configuration, which I think is just here, that can be options dot configuration. Some of this kind of metadata stuff could also come from the compilation options at a later date. So compile file is going to pass the file, and then call compile. So the compile call gets the stream to write the output to, the stream to write the symbols to, and the syntax tree. What do we actually want to do with the options in the compile? Do we need the options when we pass earlier on? I don't think so. I think we've got, this is just an abstract syntax tree at this point. So all of the actual complex stuff happens in here. We might need to pass the options into the binder. To create a scope. Then if we manage to bind the tree, we then call emit. And that's, I guess, where we're going to want to use the compilation options. I'm just trying to decide whether or not the output name should go into the options too. We're calling emit from a few places. No, we're just calling it from there. It feels odd to have these two streams and then the name, the parameter ordering already feels broken. So we call compile single from? So that's only called from there. So this output path being computed, and then we call compile file. So it's basically this compile single is just a way of defaulting the output path. Compile file is yeah, that's the actual real compiler. Source options output. So if the output path computing the stem there just so that we know what to name the DLL, but we also use a stem later when we compile. So it was in emit, wasn't it, that we actually might need to do something special. So down here we make main. So I don't think so we emit $script body, and then if it's a main, if it's an executable, we do that. How many places call emit? How many places call compile? So the evaluator also calls compile. So if we take an options there, and then we take an option there. Compile file calls compile. Pass the options down. Emit needs to take an options. So the first one is just, we can do if options dot Don't know what this is yet. Options dot output type is exe. So we'll only generate the main method if we actually are producing an exe. Then in this, we're creating this root context and we're producing this named lambda. This is where we emit the body of the method. So if you have source code like here, that's probably not the best one. So this is actually the body of something that we need to, in .NET, generate a method to hold that function. We can't just like have stuff at the root level, because in .NET assemblies everything is a type which has methods. So the way we model this is that we have a class called script program which has a method on it called script body. When we're generating an executable, we will generate a main method as well that calls the script body and unpacks the end result so that you get an exit code that matches what you'd expect. But we don't necessarily always want that to happen. I'm not sure where we want to put the script body when we are generating a library. Maybe we want some kind of like static initializer that's going to call it. Part of the problem is that we don't necessarily define these functions ahead of time. So the way that things work in F# or C# is that I have this file that has these functions in it, and I know a compile time that this is the eval function, this is the external wrapper function, and so I can produce a type. This is what F# does, it produces a type that represents this module. So I'll create a class called eval, and then I'll put a method on it called external wrapper and another one called eval, and then it'll like put all of the arguments in and the return types and mark them all up with types. When we have a look at something from our scheme, we have this definition here for swap, but there's nothing to stop someone redeclaring swap or just assigning to it at some other point. So I could do something like set swap, and then I could just set it to, well, I could actually set it to something that's nothing to do with being callable at all. And then if I do This is a swap it. This should compile. It shouldn't be upset. Incomplete pattern match. The compiler itself doesn't compile. Eval 27. Yeah. So we need some options in here. So our options are going to be configuration, I think we can just do debug, hopefully, and then output is just going to be script. And is that going to be upset? I need to open options. Yep. Does it compile now? Here? Yes. Lib. Finally. Not the best of typing there. Build configuration, where we're talking spec tests. Okay. Options. Options is debug. Output type. What are we doing here? It's actually running it, so I think it wants to be an XC. And that needs to be let. Run the tests. Find out whether or not everything still works the same way. The only thing we're doing different now is no, that's the one I actually changed, isn't it? So that's swap it. So let's go run that again. the exit code is showing that it's thrown an exception because I tried to call something that was not a callable. And so effectively what happens is just we assign the number 123 to the location swap, and then we try and call it as if it was a function pointer. So we try and reinterpret that as some .NET delegate type, call through it. Usually bad things happen. .NET's pretty forgiving about that. I mean, probably shouldn't be, but it's the trade-off you make with VMs, isn't it? That you either can check every single thing conforms to your language specification, or you can just say don't generate code that does this, and then have the VM just crash at runtime. But the point I was trying to make is that swap may not be what is defined here. I think we'll have to come back and solve this at a later date when we do scheme libraries. So as part of the scheme specification, there is a way of writing libraries. So that's good.